you the Dr. Masatoshi Sana. He is a president of Japan Legal Orthodontists Association. He's board member of World Board of Lingual Orthodontics, active member and titular member of European Lingual Orthodontics Society, member of World Federation of Orthodontics. Only a few things about Dr. Sana. He was the winner of 2 awards in the meeting of London. The first one was the best presentation, and the second one, the 5 best cases presented in London. So, we are only on the top. So, over the top, Dr. Sana speaks us about clinical lingual orthodontist treatment with consideration for the differences between the labial treatment and biomechanics based on statistical evidence. Please, Dr. Sana.
Thank you for the introduction. As just mentioned, I am Masatoshi Sana, President of Japan Legal Orthodontic Association. Before we begin, I would like to express my appreciation to the President of ESLO, Dr. Vittorio Casciapesta. Vittorio Casciapesta and everyone in the committee. And thank you for inviting me to speak. I would like to express my gratitude for the relationship extended to JAROA by ESLO. I have participated in the most of Congress held by ESLO, and I especially hold the Congress held in London, where I was awarded the best 5-case presentation, dear to me. I consider this to be one of the most memorable moments of my practice. Today, I will address clinical lingual orthodontics treatment with consideration of the differences between labial treatment and biomechanics based on statistical research. I hope that this presentation will be informative in future practice. In the past, lingual orthodontics have been known for certain characteristics, such as tendency of lingual tipping of upper incisor, difference of transverse bone direction from labial orthodontics, and strong anchorage, and others. In some cases, these features have been seen to create insufficient results, such as long period of active treatment and so on. Now, what kind of research is needed for solving these problems? I believe that our answer lies in defining the features of lingual orthodontics with quantification. For example, regarding inclination of incisor compared to labial orthodontics, what is the variance of degree in overtalk application, which is optimal to the upper and lower? How often does the transverse bone effect occur? And when it does? And these some differences regarding transverse bone effect on upper and lower. If some differences do exist, how much and where? Even though many expert lingual orthodontists imply the necessity of overcorrection and the existence of transverse bone effect, only few studies were found regarding the amount of overcorrection and other lingual orthodontic features which are based on statistical research. Possibly, application of half-lingual technique, crossover technique, and others made the research difficult. Today, I'd like to introduce the result of our research, which was conducted to make the features defined more accurately. This figure shows evidence level. From past years, lingual orthodontic features have been explained by expert lingual orthodontists. I would like to raise the level regarding features of lingual orthodontics. We have adapted the recommendation regarding talk and action to many patients, but there being racial differences, difference of type of malocclusion, recommended value is not always proper value for each patient over various races. Our research is not refute RCT, but a result of a trial to raise the level of lingual orthodontics. We classify the 120 cases into 4 groups. linear or labial or extraction or non-extraction cases. Labial cases incorporated loss prescription type places. Linear cases incorporated indirect boning system from non-nova correction setup models. Cephalograms and models were used to measure. Cephalograms were used for pre and post. Data models were used for pre-post and post-retention. This is a result from lateral cephalograms of extraction cases. Left is labial case, right side is linear case. Regarding inclination, linear cases were inclined to linear 5.3 degrees more than labial orthodontics. Regarding AP change, linear cases were moved to linear 1.6 millimeters more than labial orthodontics. Regarding vertical change, labial cases were slightly intruded than linear orthodontics. This table shows the actual numbers. This is a result of the lower incisor movement in extraction cases. Left is labial case, right side is linear. Regarding inclination and AP change, no significant difference was found. But regarding vertical change, linear orthodontic cases were significantly intruded, about 2.1 millimeters at root apex. This table shows the actual numbers. Linear inclination is usually accompanied with elongation. Therefore, intrusion force will be needed for upper incisor. For lower incisor, overtorque and intrusion force is not required. Consideration for lower incisors show tendency of intrusion after treatment. Extrusion force is allowed during treatment. This is a figure of biomechanics of vertical anti-bond bend. When the top of anti-bond curve placed here, due to the difference of rebounding force, extrusion force will occur on this side, and intrusion force will occur on the other side. Based on our statistical research, which type of anti-bond bend is correct on the upper and lower? Based on the result of this study, for intrusion of the upper incisor and extrusion of the lower incisor, this type of anti-bond bend is correct. Next point is regarding torque expression. As I expressed before, amount of our torque in labial orthodontics is 5 degrees from loss prescription. In the studied linear cases, over torque was not applied. On the average, linear cases was inclined to linear 5.3 degrees more than labial cases. From this study, in linear setup, over torque is seen to be necessary and the amount considered to be 10 degrees. In either of methods of treatment, additional wire control is of course needed. Then, how is the torque expressed accurately? We can find two ways. One is expressed from a setup model, which is programmed with overtorque. Another way is to twist the rectangular arch wire. To add my explanation, the purpose of these two ways are not to prevent the torque loss, but the expression of the torque. The first way is using setup model, which is programmed with overtorque. Advantage of this method are simplification of the wire bending, and amount of torque is more precise because it is done in the laboratory. Disadvantages are brackets are located on gingiva, showing the interbracket distance. Difficulty of three-dimensional control in adjusting can occur. Depending on the case, the bracket positioning can become more difficult. crown height adjustment will be difficult with torque expression. This slide shows why over-torque application causes the shortening the interlocket distance. When the over-torque is applied, we need to check the interlocket distance and interference of gingiva. Next way to express the torque is to twist the rectangular wire. Advantage is keeping the interlocket distance, and optional torque application is available. Disadvantage is bringing complicated chair side work and extending the chair down. And we have to recognize that if twist is applied to the preformed arch wire, a needed second order bend will be incorporated. This slide shows unneeded second order bend, which was made by the twist of the preformed rectangular wire. One of the solutions of this problem is to apply torque using straight wire and current. This is a test piece and blueprint to decide the size and angle of groove of turret. This is a final product turret which can be used to bend beta titanium wires. I'm going to show you the video. This is a movie that shows how to apply the torque to straight wire using a turret. This turret is of my design, which has a groove to apply torque to beta titanium wire. I designed the diameter of turret to 30.3 millimeters and curves the groove 0.017 by 0.025 inches in depth at a 15-degree angle. We decided this prescription from experimental research. You can get this turret from Task, which is a Japanese orthodontic supply company, from next month. This is a result of the torque applied without the unneeded second order. As a conclusion, we compare the tooth movement in the labial and lingual orthodontics using dental models and lateral cephalogram. In labial and lingual extraction case, difference in features were found in anterior teeth movement. In lingual orthodontics, difficulty of torque control was a concern and suggested that the proper additional over-torque be about 10 degrees. Upper incisor is more difficult to introduce than lower, and lower incisor was more intuitive than the upper. So change in the anti-bowing curve is recommended. Next, the research of models will be looked at. Arch length and width were measured. The measurements were taken from this specific point, from functional curves to functional curves, from functional curves to functional. This is a result of extraction case. In labial cases, degrees of lower arch width was observed. In lingual cases, degrees of upper molar arch width and lower second molar width was observed. Okay. Once again, result of extraction cases will be looked up. On the upper arch, molar arch width narrowed gradually from premolar to second molar, but on the lower arch, significant change was not observed from premolar to first molar, but second molar width became narrow. Next, the result of the measurement of extraction cases of retention over 2 years past will be looked at. With both labial and lingual treatment, allowed variance level was observed, but there was specific difference between the variance which would be considered characteristic to the treatment style. As for the lingual extraction cases, lower second molar expanded. During treatment, second molar width became narrow due to lingual inclination, but during tension, applied second molar was found. Measurement from linear models. Variance from labial in transverse anti-flowing effect was found. And movement in the upper and lower variation was found. In the next slide, I'm going to show you the solutions. Solution: 1. Setup modification. 2. Arch wire modification. Linear inclination is easier for upper molar in linear orthodontics. Therefore, to apply backer inclination to the upper molar setup is an ideal. Linear inclination is easier for lower second molar in linear orthodontics. Model analysis showed applied in during retention period. Therefore, to apply backer inclination to the lower second molar setup is an ideal. Next, I'm going to show you the forms of anti-transverse bond method. Slightly expanding at K9 to K9 with on both arch. At molar area, expanded end gradually strengthens its application on the upper arch. Gradually. On lower arch, amount of arch expansion is not so great, and only second molar area should be expanded. All of these were result of our research and gained from the suggestion to the clinical adaptation. Next step is to be more statistically precise. For example, one solution is to increase the number of materials and classify the materials in more detail. But if the plan the goal before treatment is not reliable, high quality treatment result will not be gained. Establishing precise treatment goal is very important. Okay, from here, I'll show the best 5 cases of ESLO milling in London, which I mentioned in the beginning. And we will focus on case number 2. Angle class 1 crowding, 24 years, 6 months female. And there are facial photographs. From lateral view, patient profile was convex. Frontal view was almost symmetrical. Master strain of mentalis was shown when patient lips closed. From smile view, upper incisor was protruding. These were patients' intraoral photographs. Angle class 1, overjet plus 0.0, overbite plus 4.2. Upper midline was shifted to right 1.0. Maxillary arch length discrepancy minus 7.3. Lower arch length discrepancy minus 8.1. Narrow dental arch and anterior crowding was shown. From lateral cephalon, skeletal relationship was almost class 1. Maxillary incisor was inclined lateral. Mandibular incisor was inclined lingual. Upper and lower lip to line was protruded. Looking at panoramic X-ray, 18 was absence, 28, 38, 48 were impacted. This is a treatment plan. Extraction passed by caspits and makes a headgear for reinforcement anchorage. And indirect bonding both arches, leveling, retraction, and implantation on lower bacoalveolar bone for more major movement, talking and detailing. This is a picture is when indirect bonded to the upper. Initial arch wire was 417 square kappa 6 months later, during leveling. Photographs of during leveling over the upper and correction of carboxy of the lower. These photographs were taken just after implantation of the lower for measured movement of molars. Continued retraction. This is a detailing stage. After debonding, upper and lower lip line were improved. Profile was brought to plan. Lip closure was possible without strain. Active treatment period was 3 years. Class 1 molar relationship was established and no malversions and no normal over white were gay. Severe cladding was in blue. Scatter class 1 was maintained, and upper and lower incisor inclination were improved to normal. From superimposition, mandibular plane was closed 2.1 dB. The control tipping of upper incisor and the inclusion of lower incisor was shown. Anchorage of upper was almost unmoderate. Measure movement of lower molar was shown. This slide shows 2 years and 1 month later after debanding. From intraoral view, occlusion was seen to be stable. Almost same data at out of retention at the time of debanding. From top to bottom, before, after, and out of retention. This concludes my presentation. In order to treat patients to higher quality treatment, it is essential to evaluate the result by understanding the tendency of treatment. I feel that the most valued aspect of this ESLO conference is being able to present and communicate and learn from each of the participating doctors regarding orthodontics so that we can advance. I appreciate your patience. Thank you.
Some question for Dr. Sana.